So on these, we need to determine if they have real or complex roots. The quickest way to do this would be to just graph them. On your graphing calculator, you could just graph them. If they intersect the x-axis, they have real roots. If they don't, they have complex roots. But if you're taking a Burbank High test, there's no graphing calculators allowed. So let's talk about another way to do this. The quadratic formula is this: negative b plus or minus the square root of b squared minus 4ac all over 2a. Complex roots are roots that have I in them. And I comes up when you have a negative in a square root. So really, all we need to determine is this negative or is this positive? This quantity right here, b squared minus 4ac, is called the discriminant. And if the discriminant is negative, it means we have a negative in the square root, and then we have I in the solution, so it would have complex roots. If it's positive, there's no problems. It would have real roots. It would intersect the x-axis. So let's find the discriminant's value for each of these. B is 5, so 5 squared minus 4 times A is that 3, times C is that 4. Here we have 25 minus 48. That equals a negative number. Since it equals a negative number, we'll have a negative in the square root, and this is going to have complex roots. Now let's do the same thing over here. B squared would be 5 squared again, minus 4 times 3 times negative 4. The negative times a negative is going to make a positive. So we have 25 plus something. So this is going to be a positive number. That means this is going to have real roots. Now there's one more situation. What if it's not negative and what if it's not positive? What if it's exactly 0? If it's exactly 0, it means it has one real root. It will look like this in a quadratic situation. If it has one root, if it intersects the x-axis at exactly one spot, it means the discriminant is 0. Here's why. The two intersects that we normally have arise from this plus or minus. If you have two intercepts, like in this situation, the plus or minus is what's producing the two solutions. If this is 0, if you add and subtract 0, you end up with the same thing. So you end up with this situation. And so if it's a negative discriminant, that's like this. This would be complex roots. No x-intercepts. So this is negative discriminant. Discriminant is 0. This is positive discriminant. And check your math notes in your book for more information on that.